Good morning to all. I am Jayanthi, working as an assistant professor at KSR College of Engineering. Today, we are going to see about the topic abstract data type. An abstract data type is given by data as well as set of operations to be performed on the data while hiding implementation. That means only the set of operations is defined, that implementation is hidden. Stack ADT is a example. It is here we are adding an element and removing an element. We are using the push and pop operation, but that internal, how it is added or deleted, it is not represented. So this is an example of abstract data type. The set of operations are insert, delete, search, replace, assign, and inform. These are examples of abstract data type. Next is benefits of using ADT. So if you use ADT means code is easier to understand. Implementation of ADT can be changed without requiring changes to the program that uses ADT. We use modularity. These are the benefits of using ADT. List ADT. A list is a linear collection of elements. A list is an ordered set of elements. List is an ordered set of elements. Here we are having that elements from 1 to up to n. N is the last element, that is A1 is the first element of the list. A2 is the second element of the list. N is the size of the list. So if the element is at position I means it is AI. Before the element AI is predecessor and after the element AI is successor. The successor is calculated by AI plus 1 and the predecessor is calculated by AI minus 1. The operations performed on list are insert, delete, find, next, replace, print, and make end. These are the operations performed on the list. So that insert XML file, insert the element X after the position 5, delete X, the element X is deleted, find X returns the position of X, next I returns the position of the successor of element I plus 1, this returns the next element. Previous means returns the position of its precedent is I minus 1. Printing list is it will display the elements in the list. Make empty means it will make the list empty. Next one is implementation of list ADT. So it is array based implementation, linked list based implementation. There, list can be implemented in two ways, that is array based implementation and linked list implementation. So first one is array based implementation. Array is a collection of similar type of data stored in consecutive memory location. In array, we have stored an element in the consecutive memory location. But in linked list, if we have not continuous memory space means we can allocate a list. In list, it is stored as a node. Array is a collection of similar type of data stored. If we have to store 100 elements means if these 100 elements have the same data type means only we can store in an array. For example, if we want to store and register number of a student, the register number of a student is of int data type. So the 100 elements are of int data type, so we can store. But if we want to store the register number, name, and the initial means, for example, if register number is of int data type and the name is of string data type and that initial is of character data type. So these are the different data types. We can't able to store in an array, but in the if we declare an array means we have to store the same data type of element. Example, array is a static data structure, that is memory should be allocated in advance and the size is fixed. If we want to use an array means we have to first at the computer itself we have to give it the size of the array. Here for example A is 20, A20 is the size of the array. That means 20 memory spaces are allocated. If we use, for example, if we firstly allocate the 20 memory spaces means we will use only 10 memory space means that remaining 10 space will be waste. So this is one of a disadvantage. This will waste the memory space when use space is less than the allocated space. So if the used space is less than the allocated space means the remaining space will be waste. This is one of the disadvantage of array. This is an array-based implementation. So array indexes start from 0 up to array size -1 is the class index. So it starts from 0 to n-1. So here we can store that element. This is one of an example. So the operations performed in an array. The operations performed in an array are creation of an array list, insertion of data in the array list, deletion of data from an array list, display all data in the array list, searching for all data in the array list. So these are the operations performed in that array. So while inserting an array, we have to check whether the array size is full or not. If it is the array size is full, for example, if it has an array size of 5, already we have stored in 5 elements, it means we can't be able to insert another element because the size is full. So this is made up. Define that max size is of 10. So that max size is of 10 means we have declared that array size of 10. That is, we can store the 10 elements, that is index from 0 to 9. Starting index is 0 to 9. And the ending index is 9. Starting index is 0 and the ending index is 9. So create operation. So this using a create operation is we are going to create an array. Create operation is used to create an array list with an n number of elements. If n exit that array's maximum size, then the elements cannot be inserted into the list. If we declare the size of array means 10 means we store only 10 elements. Create void create. So this is a method name. So here we declare a variable I. Printer. In the printer we have given the internal number of elements to be added in the list. So here we define the size as 10. So the total array size is 10. If we declare that 5 means we have to enter 5 elements. So in this printf, we enter that array elements, that is by using for loop we are getting the elements. At initially I value will be 0. So that the array index will be start from 0. So here we given array index. So given that I value as 0. So using scanf, we have getting that input from the user. So here ARR of 0. The first element is given by the user is stored in the location of 0th index. So ARR of 0, first element is stored in the 0th location. And then up to that 4th index, up to 4th index, it will get an element and store it an array. But initially I value will be 0. So first element will be stored in the 0, then I value will be incremental. Then the condition is checked, 1 is less than of 9, the condition will be true. So ARR of 1, the second element of the user is stored in the first location. So this will be repeated until that 4 is less than 5, until this condition. If 5 is less than 5, if 5 is implemented, 5 is less than 5 means condition will be false, it will come out of the loop. So totally they are the 5 elements will be stored in an array. Here for example, n is equal to output means the output will be stored like this. So that index will start from 0 to that n minus 1, here that n is 6. So n minus 1 is 5 up to the 5th. So totally they are the 6 elements stored in an array. Insert operations. So insert operation is storing a particular position in an existing list. We are going to insert an element in an existing list. Inserting the element in the last position of an array is easy. So in that array, inserting a last element is easy, but the element in particular position or at the first means it is a bit difficult because we have to check the element right. For example, if we consider an array means here we are storing the 5 elements, that is 10, 20, 30, 40, 50. Suppose we have to insert an element at the this position means that is second position means we have to shift an element to the right, then only this space will become free. So here we are shifting from first we have to shift this 50 to the next location, then 40 to the next location, then 30 to the next location, then 20 to the next location. Then only it will become free. So that A of I here if we consider A of I means it will move to the A of I plus 1 position. So if we move means that then the space will become free. Then only we have to insert. So in array insertion at last is easy, but in the middle or at first position is difficult. So now we are going to see the coding for insertion. So here this is an in printf you have entered the position that you want to insert. So by using this scanf, we have gotten position from the user. So that insert means from the already created list, we are going to insert an element at particular position. So that position will be within a size of n. So here we are checking if it is the position is greater than of size n means that is array over 4. For example, here we are having that array size of 5. So that here we have shown the 10 elements. If the value is less than 5 means we can able to insert. If I give value is 10 means we can't able to insert. Within a list only, within an array only we are going to insert. So that the position will be. So if we given that position that is less than n means we can insert. If this condition is false means else block will insert. So in the else block we have to shift an element, that is then only we have a space to insert an element. So first we have to move that last element to the next position. So this last index can be found using the array size -1. So for that purpose they are giving I is equal to max -1. Max is that is then max is 10. So we are going to we moving that element to the. So first of all, it will point out that last element. Then it will check the position. So in that I, that is that max -1 will be. So it will indicate that last position. So that position -1 means if that up to that position -1, it will means we have given that position 2 means, for example, if we given the position 2 means up to that first location we have to move an element. That is here that index can be, we have given that position 2 means here we are going to insert an element, but we have to move up to this element. So this is an index of 1, so that we have given the position 2, so that position -1 up to this we are going to move. So first the max -1 means it is pointing that last element in an array. So in ARRA means it is pointing that last element. So here we are moving that to the right. So ARR I plus 1. If the element is at fifth position means ARR I plus 1 means it is moved to the sixth position. So this can be performed until the first position. So after this, the first position will be like this. After this code is executed, all up to that given position, the elements are shifted to the right. So next, it will ask the user to insert an element, that is to enter an element, enter the elements to insert. By using the scanner, we are getting that element and stored it in that variable of p. So array of position. Position means we are giving that, if we are giving that in that position, the element will be stored. So n plus plus means if we are already having n 5 elements means here we are having the 5 elements. After this element is inserted means one element will be added. So n plus plus. So only they are giving that n plus plus. So after that display method will be called and display that array. Deletion operation. Deletion is the process of removing an element from an array at any position. So deletion means removing an element from an array, deleting a same way as insertion, deleting an element from an empty city, but in that particular location or at first position means it is difficult because we have to shift that left. This is an example. Suppose if we have to delete an element 20 means if this element is deleted means we have to move the 30 to the left, 40 to one bit left, and 50 to one bit left. So this is before deletion. After deletion means 20 will be deleted. So that 30, 40, 50 is shifted to the left. So it will require a lot of movement. If we store 1000 data means that in that year deletion is difficult. This is an program. So here first of all it will from the user gets the position to delete. By using the scanner we are giving the position. Suppose if the position is greater than n means as same way as in the C in the insertion, it will be an invalid location. Suppose if this the position is less than of n means we can be able to delete. In the else block, this for loop will be executed. I is equal to position plus 1. So position plus 1 means if the position is 1 means the position on plus means 2. So in that element in that second position is moved to the left. So that it is moving the 1 bit to the left. So of ARR I minus 1. So that element in the ith position is shifted to the previous position, that is previous position, so that ARR of I minus 1. So after this, if we delete it, so this will be continued until to that we have given that position. So afterwards, n minus minus means if we have here we are having the 5 elements. After deleting one element from an array, the size will be minus if the position is greater than of n means so that array is overflow. So if we given that position that is less than n means we can insert. If this condition is false means else block will insert. So in the else block we have to shift an element, that is then only we have a space to insert an element. So first we have to move that last element to the next position. So this last index can be found using the array size minus 1. So for that purpose they are giving I is equal to max minus 1. And max is that is then max is 10. So we are going to we moving that element to the. So first of all it will point out that last element. Then it will check the position. So in that I, that is that max minus 1 will be. So it will indicate that last position. So that position minus 1 means if that up to that position minus 1, it will perform the operation. So here that max minus 1 means last element, that is position minus 1 means we have given that position 2 means, for example, if we given the position 2 means up to that first location we have to move an element. That is here that index can be, we have given that position 2 means here we are going to insert an element, but we have to move up to this element. So this is an index of 1, so that we have given the position 2, so that position minus 1 up to this we are going to move So first, a max minus 1 means it is pointing that last element in an array. So in ARR means it is pointing that last element. So here we are moving that to the right. So ARR I plus 1. If the element is at fifth position means ARR I plus 1 means it is moved to the sixth position. So this can be performed until the first position. So after this, the first position will be like this. After this code is executed, all up to that given position, the elements are shifted to the right. So next, it will ask the user to insert an element, that is to enter an element, enter the elements to insert. By using the scanner, we are getting that element and stored it in that variable of p. So array of position. Position means we are giving that, if we are giving that in that position, the element will be stored. So n plus plus means if we are already having n 5 elements means here we are having the 5 elements. After this element is inserted means one element will be added. So n plus plus. So only they are giving that n plus plus. So after that display method will be called and display that array. Deletion operation. Deletion is the process of removing an element from an array at any position. So deletion means removing an element from an array, deleting a same way as insertion, deleting an element from an empty city, but in that particular location or at first position means it is difficult because we have to shift that left. This is an example. Suppose if we have to delete an element 20 means if this element is deleted means we have to move the 30 to that left, 40 to one bit left, and 50 to one bit left. So this is before deletion. After deletion means 20 will be deleted. So that 30, 40, 50 is shifted to the left. So it will require a lot of movement. If we store 1000 data means that in that way deletion is difficult. This is an program. So here first of all it will from the user gets the position to delete. By using the scanner we are giving the position. Suppose if the position is greater than n means as same way as in the C in the insertion, it will be an invalid location. Suppose if this the position is less than of n means we can able to delete. In the else block, this for loop will be executed. I is equal to position plus 1. So position plus 1 means if the position is 1 means the position on plus means 2. So in that element in that second position is moved to the left. So that it is moving the one bit to the left. So of ARR I minus 1. So that element in the ith position is shifted to the previous position, that is previous position, so that ARR I minus 1. So after this, if we delete it, so this will be continued until to it we have given that position. So afterwards, n minus minus means if we have here we are having the 5 elements. After deleting an element from an array, the size will be minus. So here we are giving n minus minus. So after that, after deleting that, we are printing an array that is starting is I is equal to 0. This is an array of index. So first ARR of 0 means it will print 10. Then I plus plus means will be incremented by 1. So 1 is less than of n. Addition will be true. So ARR of 1 it will be at 30. Then until that until last index it will print. So next one is display operation or traversing a list. So traversal is the process of visiting that element in an array. Display operation is used to display all the elements stored in the list. Elements are stored from index to end using a for loop. The elements in a list are viewed. So traversal is a process of visiting that every element in an array. We have to display an element from 0 to n. By using the for loop, we are traversing each element in a list. The next one is the search operation. So search operation is used to determine whether a particular element is present in a list or not. If we are stored that 100 elements in an array means we are giving a particular element. From that array, it will search and see whether that element is present or not. So input the search element to be checked in the list. So that input is picked from the user and it is searched in the list. So routine to search an element in an array. Why the search? Here the search is a function. So here we are giving the variable as search I count, and the count is the initial value is will be 0. So enter that elements to be searched. So first of all, it will get from the user, it will getting an input that is stored in the search. For example, if I am giving 40 means it will stored in that variable search. So up to that first. So we have to search on each element within the element stored in an array. By using that for loop, so same as here for traversing in an array, we are using that for loop. Here we are also traversing. For search also we need to traverse and to check that each element is matches to that search element. So here suppose we have the search as 40 means in the ARR of 3 means suppose we are having that element is 40 means at first step we have checked that ARR of 0. Here first initially I value will be a 0. So this will be not matched, and then so this count this loop will be not be executed, and then the value is implemented I of 1. So here is also not matched. Then if we repeated this means ARR at ARR of 3 the search value will match and the count will be incremented. If this loop will be incremented means the count value will become 1 or 2 at if the element can be more than one time, at the time the count will become 1, 2 or more than of that. So if this loop is not executed means that initially we have declared a count as 0. So at finally the count value will be 0. So if the count value will be 0 means element is not presented in the list. Otherwise it will be presented in the list. So if count value is 0 means element is not presented in the list. If the count value, that is if this if loop is executed means the element is presented in the list. So these are an advantages of array. So the elements can be faster to access using random access. We can access faster. Searching is an easier. Limitation means it needs a consecutive memory locations. If we have consecutive memory locations, means then only we are able to store an array. The number of elements in the array is fixed and it is not possible to change the number of elements. So that at that current time we have already given that size of an array. So at current time we are not able to change the size of an array, but in a linked list we can overcome this disadvantage. So insertion and deletion operation is an array is an expensive because it need a lot of data movement. If we have to insert an element in that middle means we have to move that right. We have to shift the elements to the right. If we have to delete an element means we have to shift the elements to the left. So this is this will became very complex operation. Application of array is used in vector and matrices as well as many databases. One-dimensional array is the so it can be used to implement list, heap, hash table, queue, stack, and it can be used to determine partial or complete control flow in program. So here is the difference between array and a linked list. Array is a collection of elements having the same data type with common name. Here we are giving that array name as common, but in a linked list, it is collected by link and pointer. Here we have that in the linked list, we have a data part and the address part. In the address part, we have stored the address of the next node. So this is a difference. This is the next one is access is here that we can access an element using an index or subscript. Array element can be accessed using an index or subscript. But in access using a linked list sequential access, we have to travel from that first element. If we have to reach the fifth position, means we have to access that element from first. Then only from the first element only we are going to move up to the fifth element. The memory structure is a contiguous memory location, but in the linked list it is an stored at an available memory space that is not to be contiguous memory location. So the insertion and deletion takes more time in an array, but in that linked list it is easy because we are using a pointer. So by connecting a pointer, we can make insertion and deletion easy. Memory allocation is at compiled time, while in the linked list that memory is allocated during the runtime. That is dynamic memory allocation. So the types of array are one-dimensional array, two-dimensional array, multi-dimensional array. In linked list, they are single linked list, doubly linked list, and circularly linked list. In single linked list, we have only that one address pointer. That is next node address is stored in the previous node, but in the doubly linked list, the previous node address and the next node address is stored. In circularly linked list, the last node address. In last node, the first address of the last node is connected to the first node. So these are the types. So in that, as compared dependency in array, each elements are independent, but in linked list they are dependent on each other because they are stored